Hey everyone, welcome to this video. In today's video, we are going to talk about very interesting problem. I'm going to take an example of a food delivery app that you all have used, you all have seen, and look at two critical problems when it comes to event processing, when it comes to real-time streaming, when it comes to real-time aggregation and analytics. And more importantly, we are going to look at GlassFlow, which is going to make deduplications and joins absolutely easy, easier than ever. So stay tuned and watch this entire video to learn more about GlassFlow and how it solves your problems so you can focus on your business problems and not these infrastructure problems. Okay, so let's start with understanding what could be a simple architecture of a food delivery application. Now, I'm sure you all have used a food delivery application and there is typically a mobile app. Okay, so let's say this is a mobile app. Then you have your drivers who are basically accepting the orders to deliver your food. So they also have an interface. There is a driver app. Similarly, there is an interface for the restaurant. Okay, so basically, a simple food application or food delivery application also has a lot of things going on. And all of these applications are submitting transactions to your app. So let's say this is your backend application and all of these clients are basically producing transactions into your system. And what you want to do is capture when these transactions are happening, data around it, and produce events. So you can do analytics on top of them. Now, whenever we talk about events, there's one system which is absolutely critical and very common, that is Kafka. So you have events, you have transactions happening, and all of these events are into Kafka. Now, once you have into Kafka, and we want to do analytics on top of it, there's another system which is absolutely critical and very common, that is ClickHouse. So what you do, you have your events into Kafka, then you ingest all the events, have it in ClickHouse tables, and then once you have the ClickHouse tables, what you can do is have a dashboard. And this dashboard can show you all the important metrics. Metrics around your customers, metrics around your orders, metrics around your drivers, and so on. Now, this dashboard is basically just backed up by ClickHouse and you run queries. Okay, this is how you get data. Now, two problems. Going back to this simple architecture, what we have seen is there's Kafka involved. And as you might already know if you follow this channel, that Kafka provides at least once guarantees. Which means if you produce an event into Kafka, it will be guaranteed delivered, but at least once, which means it can be delivered twice, thrice, right? Depending on the failures, depending on the other edge cases and so on, which means there are going to be duplicates. Now, it's safe to assume that there are going to be duplicates and have a solution ready than to assume that there are not going to be any duplicates and have problems. So, there are going to be duplicates, and these duplicates, if not handled, they are going to go into your ClickHouse, which means that when you run queries, depending on the type of queries you run, you may show incorrect data on your dashboard. Now, what happens when you show incorrect data onto your dashboard? Well, you are looking at the dashboard and understanding the behavior of your customers, the behavior of your orders, drivers, and understanding some important customer metrics. And if this is wrong, you're going to make some bad decisions and make your life harder. So you want correctness. Correctness is absolutely critical. And given that you have these three different sources of data, and there can be more depending on the complexity you add, depending on the number of dimensions you want to run analytics on. There can be multiple stream of data, and then what you want to do is aggregate them, you correlate them, right? So basically what you want to do is on this dashboard, you want to show aggregated data, correlated data, which means even if there are multiple sources of data, you want to join them all together and then produce some results. And these are the results that you want to show on your dashboard. Now the problem is, typically, if we talk about ClickHouse, if you want to join multiple tables in ClickHouse, it's not going to work well if you have a large data set. ClickHouse does not recommend more number of joins on large data sets because it is not designed for that. It's absolutely amazing system for real-time aggregations, running analytical queries, but it's not meant for relational type of joins, especially when you have large set of data and too many joins happening. So, two problems. One is duplication, where you can just have multiple events for the same thing in ClickHouse and end up having wrong data on your dashboard. And then the performance part, where you want to join multiple data sets and then your query performance is really slow. Okay. Now these are the two problems and we want to look at what are the solutions. Now when you talk about ClickHouse, there is a engine called replacing merge trees. Now what happens is, you emit an event, okay? You have an event, and then, for example, you have 1, 2, 3, 4, that is the ID. Yeah, let's say this is orders data, and then you have order value, let's say $40. Then you have some timestamp when the order was placed, probably customer ID, who placed the order, and so on. Okay, but when you have duplicates, you will have multiple of these. Probably timestamp T1, T2, and so on, but it's going to be the same, right? So the data is same, it's just twice. And if you, let's say, try to calculate, okay, give me the total order value for this customer, so it's going to be $80, which is wrong. It should be 40. Okay. Now, in ClickHouse, when you produce an event, you can specify that, okay, there is this ID, which is primary key, and ClickHouse will kind of try to merge these two entries and reduce duplicates using either, let's say there's a version column, let's say you have a version, and you say V1, V2, so it takes the later version and it will just take this row and try to remove this row, okay? Or if there's no version column, it will just see, okay, what is the timestamp, try to deduce that, okay, this happened later, I'll keep this and remove the other one. But all this in ClickHouse is happening in a background process that runs asynchronously. And basically you don't have any control on that, when it will run, how long it will take, and so on. So which means that in your table, the data is going to be there in a duplicated manner, and some async process is going to run, replace your data, and have it clean with no duplicates. So which means you cannot actually rely on this background process, which means you can still have incorrect data. So it's not actually solving a problem, but it also provides you to force trigger this process and always have correct results without duplicates. But when you say final in your queries, it actually triggers this background process, and again, it can take longer because depending on the data set size, how many new rows you have inserted, and so on, it can take really long time. So it works when you do not want immediate effect. of deduplication. But eventually you want your data to be clean and with no duplicates. This will work, but not in a streaming fashion when you really want to avoid duplication right away. As your data goes in, you never want to see incorrect results. This is not going to work, but this is still a good approach when you want eventually deduplication. The other part or other solution that could work is materialized views. Okay, which means, as the name suggests, basically what the core idea is that you pre-compute. Whenever you insert data, you pre-compute some aggregation and then show it to the customer. For example, you have your insert, you insert some data, okay, and then you have your materialized view, which is, let's say, select from this table, select from that table, and then transform and basically store the materialized view of this data using multiple tables. So what you're doing is, whenever you're inserting a new row, there's a change, this materialized view update will be triggered, and then multiple tables will be joined, some aggregation, let's say the dollar value of the order, let's say $40, right? That will be updated. Let's say there's a customer who already ordered for $40, he adds another order for $30. So this materialized view will automatically update to $70. So the idea is to pre-compute, right? And whenever there is a new data coming in, it just pre-computes and figures out what's the latest value, which means, since it's pre-computed, when you do a select star or select count or something like that, just running some queries, you just take the data and give it to the user, which means it's really fast. You're not doing any join, you're not doing any transformations, you just get the data. It's really fast. Now, the downside is basically your materialized view can impact your insert performance. And still, if you don't do it in a sync manner, you may end up having incorrect data for a while, because the materialized view may not have been updated and you can still get the data from old materialized view. And the other problem is that if there are tables which do not have any inserts, it will not trigger the materialized view, right? For updates and deletes and stuff like that, it won't work. So while this is a good solution, this works for many use cases, it's not the best solution for other use cases, and it's not ideal. We want something that simply works. The other solution is, which I've also seen commonly used, is using something like Kafka streams, or let's say Flink, and basically that sits between your Kafka cluster and your ClickHouse cluster. Performs a deduplication and also joins, and then publishes data to ClickHouse. Similarly, instead of using these systems, some people also use databases to just have some deduplication logic on their own, like DIY deduplication. Some also have some Redis clusters to just do a quick check if there's already this key and so on. So there's like custom implementation that you could do. You could also use some sophisticated systems like Kafka Streams, KSQL, Apache Flink, and so on. The problem is, it will work. It may also be performant, but the effort that is required is massive, right? Because you have to write custom logic, you have to maintain it. Maintaining such systems is not easy at all, right? Trust me, I've done this. It's complicated. You need good experience with these systems and then also maintain it. When something changes in your topology, when something more is required in terms of features, you need to keep it updated, and it's a pain, right? It's not as straightforward. What we want is really simple, that just plugs in, solves these problems, and then you are good to go. You are ready to solve real business problems that you care about and not these low-level infrastructure problems. So these DIY using Kafka Streams Flink is again a no-go because it takes a lot of effort. People do it when they have experience, when they have really amazing bandwidth and expertise. So not for us. Now, what could a potential solution look like? What are some key features, right? You of course want ease of use. You want to plug it in, right? Which means you don't need to change your existing architecture, but you just plug it in between your Kafka and your ClickHouse. Your architecture doesn't change. Data flows clean, transformed, and deduplicated. So it should be pluggable, it should be easy to use, it should be configurable. So no more custom coding. You just configure something like these are my keys, I want clean data. And open source. You can actually understand what's going on, right? And you can have some control. So these are the common things. Now with this I want to introduce you to GlassFlow. GlassFlow can give you exactly that. Now what it does is, it just sits between your Kafka and ClickHouse, and make sure that whatever is ingested into ClickHouse is clean, is deduped, and transformed, as in if you want to have joins. And this is GlassFlow. So what you do is, you set up pipelines, configure your data, like what is the primary key, and what you get is deduplication. But what happens when your cluster scales, when you have more partitions on Kafka? Do you have to do something here? Well, no, because it can actually understand that there is an increase and auto scale. So GlassFlow can give you auto scale workers, which means you just have to configure what you want and then done. You get a managed Kafka connector that connects your Kafka and ClickHouse and gives you what exactly you want. All right, let's recap what we have been discussing so far. Basically, when you deal with events and you want to perform real-time analytics on top of it using ClickHouse, there's always a chance that there are duplicates. And you always want to join from multiple data sets. And low latency is something that can be game-changing for your business. So what you typically want is a simple solution that can just plug into your architecture and solve your problems without a lot of hassle. GlassFlow is able to do that exactly for you, which means it just sits between your Kafka and ClickHouse. It can give you easy configurable way to dedupe your streams and help you avoid joins in ClickHouse, which is slow. Then it gives you 7 days of deduplication window, so you don't have to worry about late events. You just stream raw data into GlassFlow and then flows through ClickHouse, clean, deduped, and transform. And this is the power of GlassFlow because it makes your life easier and you don't have to worry about all the underlying infrastructure problems like state management, maintenance of the schema, and scaling up as you have more partitions in your Kafka and some other low-level things. So you just configure the pipelines. They have a beautiful UI. They also have command lines for you to create pipelines, to change some things, to visualize your pipelines and so on. So I highly recommend that you avoid overcomplicating your architecture for deduplication, joins, and transforming to clean up your data, and use GlassFlow. Give it a try. Try it out locally. They have very good documentation. I am going to attach the link in the description so you can all check it out and share your feedback. Also join the Slack community. Give it a star on GitHub if you think it's going to help you. And if you like this video, please hit the like button, subscribe to the channel, and keep watching the videos. Thank you, and until next time.